Hi, I'm Sampath. I'll be conducting the auto-scaling session. In this session, we are going to apply some load to the previously created API and see how the auto-scaling happens. Here, first let's see what kind of scaling can be performed. So there are three types of scaling. Horizontal port auto-scaling, in which number of ports in a deployment will be automatically scaled, or replication control or replica set based on the resource of CPU utilization. In the cluster auto scaling, it will automatically adjust the number of nodes in your cluster when port fails to launch due to lack of resources, or when nodes in the cluster are underutilized and their ports can be rescheduled on to the other nodes in the cluster. In the vertical port autoscaler, it will automatically adjust the CPU and memory reservation for your port to help the right size of your application. So in this POC, we are only considering horizontal port autoscaling and the cluster autoscaling. So by applying these scaling methodologies, we can quickly set up these configurations in the Kubernetes cluster. Also, it will automatically maintain the performance of the system, and it will make smart decisions by increasing the number of pods and the nodes when resource usage is high, and it will descale that once the once the utilization is low. So you only need to pay for what you use, so it will save a lot of money. So moving on to the cluster auto scaling. This is the AWS Kubernetes cluster diagram we have deployed. Here we have configured 2 nodes and ability to increase the node up to maximum 3. When CPU and memory utilization of the cluster exceeds that of the 2 available nodes, cluster auto scaling will be triggered, and by the metrics received from the metric server, and will spin up a new node. So that's what will happen in the cluster auto scaling. So in the horizontal port auto scaling, it will increase the number of port in a deployment when the load increases. So once the load becomes high, it will create new pods to cater that new resource usage. So let's move on to the demo of the so so we are using a JMeter strip to generate some load for the previously created API. So first let's see what are the APIs running in the system. So if you can see, we have the vehicle info sample to API, which was created previously, and it has a horizontal port auto scaling policy of if the CPU utilization reach more than 50%, it will scale the replicas to maximum of 5, and currently it has only one pod running. Sorry, this one. So same configuration has applied for all, and in the by using the kubectl top pods command, we can see the CPU utilization of the API Microgateway currently. So it's in a lower level since there are not any API invocation happening right now, and the memory also is very low. So in currently we have 2 nodes running, and once the resources are limited, it will scale the number of nodes as well by using the cluster auto scaling. So let's apply some API invocations using the JMeter and see the ports getting scale. So we are invoking the vehicle info sample 2. As you can see, the samples are now hitting, and we have passed the 600 samples mark. Let's see if the CPU utilization of the board has increased. So it has increased to 432 mini cores. So from the 8M, so it has increased. So let's see what are the pods currently running now. As you can see, a new pod has been started up and running. So let's stop the JMeter strip. As you can see, vehicle info, this one has been started 27 seconds ago. Since the utilization of the CPU has increased over the 50% mark of the threshold. So that's how the auto scaling work using the horizontal port auto scaling. So let's see if the number of nodes has increased. No, it's still in the still 2 nodes running. So uh, let's see how to auto scale the standard gateway. So the standard gateway is deployed in the namespace WSO2, so that we can see the difference between the Microgateway and the standard gateway. So this is the WSO2 API and is the standard gateway running, pod running. So we will check the resource utilization for this pod as well. So it's currently in a very low state since there are no any API invocation happening. So let's run the JMeter strip for standard gateway. So in here we are also invoking the vehicle info sample 2, which was created API which was created previously. So as you can see, number of requests are increasing. Now let's see again the CPU utilization of the standard gateway port. So it has increased. Let's see what are the ports running now. So it still hasn't reached the CPU HPA policy which we have defined for the standard gateway. Which was the 85%. So the target we are hitting right now is only 61%. So it still hasn't replicated into, it still hasn't created any new replicas since that. So let's again see the CPU utilization of the pod. So now we are reaching the samples 7000 mark. So it has increased to 503. I think now we have reached the target mark, target CPU utilization. So we can see that new pod has started up. So let's stop the JMeter strip for API invocations. So the new pod has started up. So let's see if the node has increased due to cluster autoscaling. Yes, so that it seems a new cluster, new node has been added 2 minutes ago. So this is monitoring the node cluster auto scaling. So it has scaled up. So so 30 seconds ago, a new pod for a WSO2 API and standard gateway has been up, but it's still not in the ready state. So let's see again if that pod is. So now it's in the ready state. So there are two standard gateways running now to cater the load which we have provided using the JMeter tree. So that's how we have utilized the scaling to overcome the high load in WSO2 API manager. So let's see again the pods in the Microgateway pods in the Kubernetes cluster. So as you can see, there are few still there are three vehicle info sample to Microgateway apps running. Once the uh, load has diminished, free select time of 4 minutes, it will start to reduce these sample to Microgateway applications. So that we have to wait for uh, free select time of 4 minutes. If you can see the standard gateway code, we have two currently running and we have three microgateways started up very quickly to cater the uh, load which we have given using the JMeter. So that's it for the session. We have another uh, thing to describe. That's the pod resiliency. That means if we want to delete a new pod, if one pod gets deleted, a new pod should start in place of that pod. So if we if we if we delete this standard gateway pod, it should start up another one. We will test that with the microgateways since it's easier to also. Now you can see these two pods are getting terminated since there are no new load coming for that. So once this termination over, we will try to remove the only remaining vehicle info sample to pod, so that we can see the pod resiliency as well. So as you can see, now we only have the one pod running for vehicle info sample to API Microgateway. So let's remove that and see what happened. So since we have defined a HPA, we always require at least one pod for running at each time. So if this pod is now getting deleted, then we should be able to see another pod started up instantaneously. So this is the pod we are deleting, so that they have spin up another microgateway for vehicle info sample to API, and it has started even seconds ago, even before terminating, even before deletion has completed for previous pod. So if you can see now, previous pod should be fully deleted, and the new pod must be available in the Kubernetes cluster. So that's it for the pod resiliency as well. So that's it for this session. Thank you.